Hello students, so here are the corrections for assignment 4C. Here we start to continue with our expansion, but this time round there are actually three special identities, and these special identities you can find them in your notes. What we do is, what happens is when we have a perfect squares like this, we can actually expand them very quickly if we are very familiar with the special identities. And of course there's a third one, one for which we are finding the sum of the two terms inside, another one for the negative, that means the difference, and of course the third type is actually the difference of 2 squared, right? So if you are not familiar with that, don't worry, I will talk about them in class in person again. But for now, for those who manage to understand how this thing works, right, here we go. So we have a plus 4, we square it, so using the special identity we have a squared plus 2a times 4 squared, so a squared plus 8a plus 16, right? So for part B, we have, again, this time around be careful, right? Because 3a is the first term here, so the 3a has to be in a bracket, the 4b has to be in a bracket. Again, brackets are very important here. If we misuse the brackets, our results will be very different. So with the correct placement of the bracket, you realize that this is actually 3a times 3a, and resulting in 9a squared. A common error by students is that if you don't put the bracket properly, you end up with 3a squared here, and that will be incorrect, right? Similarly, for the last part here, it is actually 4 squared b squared, so 16b squared. If you did not use the brackets correctly, you end up with 4b squared, and that will be incorrect. So the correct answer, 9a squared plus 24ab plus 16b squared. So over here, same situation now. So we have 9 squared minus 2 times 9 times m plus m squared, 81 minus 18m plus m squared. Now, this example for part D, just here to illustrate that even if it's a fraction, it still obey the same rule, because we say it's identity, right? So algebraic identity, being an identity means it works regardless of what's the value of the unknown. So you work this one out. 3 over 2 squared is 9 over 4. Then down here, again, you can use your calculator to actually get the coefficient properly. And down here, you get 25. So 9 over 4h squared minus 15hk plus 25k squared. Over here, this time round is the product of the difference, right? So s plus 5 times s minus 5. If you know that that's actually the difference between the 2 squared, this is what we get. So s squared minus 5 squared, so s squared minus 25. Here, same thing, right? So we have 2t in brackets. Remember the bracket squared minus 11 squared. So 4t squared minus 121. So using the same concept, without using a calculator, we can actually break down the 98 into 100 minus 2 and 102 as 100 plus 2. So this gives us the 100 squared minus 2 squared, which gives us 10,000 minus 4, which is 9,996. Here, okay, same thing, right? So we can actually simplify the what's on the right side first. So we get n squared minus a squared here. So once we distribute the negative here inside, it becomes n squared minus n squared plus a squared. We end up with the simplest form, is just a squared. And part B, again, using the same idea as 3a, right? So what happened is the value of n is now 16947, yes, because this portion here is just 16947 minus 3 times 16947 plus 3, as you can see. So we break it out this way. Now n is this value, a is this value, so the final answer is actually a squared, which is 3 squared, which is just 9, right? So yep, you can do your reflection, and I hope you have a nice day.